Water is fundamental to human development, from drinking water and sanitation to agriculture and more. You listen to Water Stories, a podcast series where you will learn everything about securing water, energy, and food security for all of us. Hello everyone, I am Juan Carlos Giraldo. Welcome to a new episode of Water Stories. California has been in the news in December and January with extreme rainfall and floods, and this situation occurs after many years of intense drought. In this episode, I will talk with our guests about their work on forecasting water supply in California and how these recent storms may help the California water conditions. For this conversation, I have as a guest two scientists from Stockholm Environment Institute, Chuck Young and Vishal Mehta. Chuck Young is a senior scientist. He has over 30 years of professional and research experience in water management issues. And Vishal is an environmental scientist with more than 15 years of experience in water resource research, forest conservation, and sustainable development. Chuck, how are you? It's a pleasure to have you again as a guest.
Great, I'm doing well. Thank you.
Oh, thank you. Vishal, how have you been?
I'm very good, JC. How are you?
I am doing well, thank you. This episode is very interesting. I have been listening to and reading about the situation in California. For example, I was listening to the news on NPR and they mentioned it in one of their latest reports. Something paradoxical is happening because despite the several weeks of torrential rain and flooding, California is still facing droughts. So to get into the background of this topic, I noticed we have some scenarios and a lot of questions, of course, around. One is atmospheric rivers, the forecasting itself, and also an important question is if the drought is over. I would like to start this conversation with some definitions, perhaps. Let's start with the definition of atmospheric rivers. Maybe Chuck.
Sure, I'll give it a shot. I'm not a meteorologist, but I think I have a basic understanding. An atmospheric river is a portion of the atmosphere in which a lot of moisture is basically moving away from the mid-latitudes around the equator and moving to the north or the south, depending on which hemisphere you're in. Why this is important, particularly in California, is these atmospheric rivers sometimes hit our shoreline, and the movement of all that moist air coming onshore and then encountering the mountains that are in California, which forces the air to rise, which causes water to condense and fall as rain and snow. So it turns out that atmospheric rivers are a very important part of the water supply for California because they can provide so much rainfall in such a short amount of time.
Vishal, what is your opinion about the atmospheric rivers related to forecasting that is another scenario?
Yes, JC, like Chuck said, atmospheric rivers are a key feature of the global water cycle. And for example, they can provide up from 30 to 50% of precipitation in the western US, coming from just a few events, which are these atmospheric rivers. Now, in terms of forecasting them, weather forecasts at the scale of the weather forecasts for like the week ahead or 2 or 3 weeks ahead, they can catch some of these atmospheric rivers. But further ahead forecasts, or called seasonal forecasts, they may not catch these atmospheric rivers. They may not be able to predict them. And so that's a little bit of a dilemma. If you're trying to predict something at the shorter scale, weather forecasting is able to catch them. You can see these radar forecasts based on their movement and their generation over the Pacific. We were doing that in January when these 9 atmospheric rivers hit the west coast. Like Chuck said, they're really important for water supply. But as we saw just very recently in January in California, they also pose a big flood risk.
Vishal, this topic is fascinating. Do you think water supply forecasting in recent droughts has been accurate or not?
Well, it depends again on your long term goal. If you're trying to predict your short term needs, then we need to look at our regular weather forecasts. So, for example, there is something that is being tried in California right now, which is called forecast informed reservoir operation. There's at least two reservoirs, Folsom Reservoir, which is a really big reservoir, and then Lake Mendocino, where we are seeing what are known as these forecast informed reservoir operations. And why is this new? To know what it's new about it is that we have to know the traditional or conventional way that reservoirs are run, which is that in the late fall and winter, when most of the precipitation falls in California, which has a Mediterranean climate, these reservoirs are actually not allowed to fill in with the precipitation that falls there because they follow a rule curve. These are basically rules that say for every week, every month, how much of the dam should stay empty, how much of the reservoir should be left empty. And that's because we are waiting for the snowmelt later in the season that's going to be trapped by these reservoirs. Now, what happens is that if the forecast is off and you've left your reservoirs empty, then what you have is a situation where perhaps you've left the floodwaters in the winter, you've let it pass the reservoirs, and then what happens is that you don't have enough water coming in from spring snowmelt. Now this happened in, say, for example, 2021, which was one of the driest years on record. And that year, the water supply forecast overestimated how much water would be available later in the season. For example, in the Sacramento River hydrologic region, the overestimation was by about 68%, and further south, almost 50%, 45 to 46% overestimations. And so last year in 2022, the governor put out a call saying, okay, we need to review our forecasting procedures and so on, which brings us to what we are trying to do in trying to improve these forecasts.
Interesting. Chuck, when I read about all the situation that happened right now in California, some of the papers or articles, they said that it's important the approach. And the approach has to do with innovation and models. My question is for you, Chuck, how are you developing the forecast right now?
Yeah, so just to be clear, our group isn't developing the meteorological forecasts. Other groups are doing that. But what we're doing that's different, at least from some of the more widely used forecasts in California, is we're taking these meteorological forecasts, that is the forecast of the rain and temperature for the coming months, and running it through a hydrological model. And an important advantage of that is that the hydrological model keeps track of things like soil moisture, which can really have a large impact on the amount of runoff that will be generated in a dry year. So that's an improvement that we're working on.
Vishal, what are you finding when you work in this situation?
Yes, so like Chuck said, the existing forecasts don't seem to be working well, especially when you have long periods of drought, successive droughts, and that's because they rely on statistical methods. They rely on equations about precipitation and reservoir levels, April 1st snow conditions. Now, what's happening is that as the climate is changing, we can't rely on past information as much. And these models are not tracking, for example, like Chuck said, they're not process based models. They're not tracking soil moisture status. And that's why we feel like we have seen some improvement. So, for example, like I mentioned, water year 2021 and even 2022, the regular ways of forecasting were overestimating water supply conditions later in the year. And when we run our models through that same time period, we seem to be showing much improved results, at least on the hydrology and runoff available in those dry years.
Oh, thank you. And Vishal, how long ahead are you guys working on developing the forecast for this particular situation?
Right now, we're using a 7 month ahead forecast, which is called a seasonal forecast. So, what that happens is that every day there's a group, John Abatsoglu's group, that produces these forecasts. You can go to climatetoolbox.org and you can find many different ways of easily visualizing these forecasts, actually. And what we do is we automate the ingestion of this data, the forecast data, provided by John's group, and we run our computer models forward in time, and that's how we do it. Now, the interesting thing is that on the one hand, since we're using a process-based model that tracks soil moisture, we seem to be doing better. But our hydrological and water supply forecast is only as good as the accuracy of the climate forecast. For example, the recent atmospheric rivers were not at all forecast by these seasonal forecasts. They missed the atmospheric rivers. That means that our models could not replicate what happened actually on the ground, which is all this flooding. Um, and so we could possibly start using weather forecasts, just like the people in the Folsom Reservoir case and the Lake Mendocino case, who are using these forecast informed reservoir operations are doing. We could try to integrate shorter term weather forecasts along with these seasonal climate forecasts.
Thank you so much, Vishal. Shaq, I was watching the news and they were talking a lot about the groundwater. So I remember the last year you shared interesting points with us about the groundwater. What is happening with the groundwater in this particular situation of floods and heavy rains in California?
Well, just as a bit of background, so we've had several years of drought leading up to this year. And in drought years, California relies very heavily on groundwater to meet the water supply requirements of agriculture and cities and so forth. This year, with all this rain that we had in January, we know that some water will have made its way underground. But we also know that it will take more than just 1 year to recover from that multi-year drought that occurred in the previous years. You know, the changes in the groundwater system are, take place over years, not just in one season. So it will take more time to recover in the groundwater system.
Now, let's talk a little bit about stakeholders, for example, the water managers, farmers, communities, and local entities. Perhaps Chuck?
Well, forecasts in general, of course, I mean, we all know about weather forecasts and how they can be useful. Maybe as far as water is concerned, it's really important to know if there's a potential for a flood coming in the near future, so that our emergency systems can prepare for it and people can be ready. But we're also talking here today about longer term forecasts. And the reason there's interest in those is because California gets most of its moisture in the wintertime, yet uses most of its water in the summertime. It's really important for farmers and for people who manage water systems for cities and people who are looking after the environment to have some sense of how much water will be around in the summer months. And so anything we can do to improve our ability to estimate how much water will be available in the coming summer is very helpful.
In all the information that I have and I read about the heavy rains, floods, etc., about this topic, all of them mention the role of water managers. What do you think? What is the most challenging task for them in this situation, Chuck?
California's weather is so variable, and that's the reason all these reservoirs and canals have been built over the years, is to try to capture the water when it does arrive in the winter and be able to store it and then use it in the dry summer months. And then, of course, some winters are much drier than others, and some are much wetter. So we have droughts some year and floods other years. So there are plenty of challenges for water managers in that type of environment. You may be, I mean, locally, we know people were scrambling to worry about flooding just a few weeks ago. And yet, as Vishal just said, even, despite all that rain, we may still be in a drought when it comes to this coming summer. So there's just a wide range of challenges.
Oh, thank you so much, Chuck. Vishal, in your opinion, what are the challenges that water managers or water management will face in this particular situation?
Yes, like Chuck said, it's really important to have a handle on, or at least some sort of um, insight on the season ahead in California. So, for example, the state's B120 forecasting system has been operational for many decades. And based on these forecasts, the State Water Resources Board has to make decisions about how much water is available, like Chuck was saying. So, for example, in 2021, the very dry year, some parts of the state had no water available, zero water available, right? Yes. So, for example, this is the US Bureau of Reclamation Central Valley Project had a zero allocation for agricultural contractors north and south of the Delta, for example. And just all across California, you see um, everybody is talking and thinking about this on, and every year. This is a very big deal. And so trying to improve the forecasting is of great interest to all statewide managers, like Chuck said, to all the farmers on the ground, the irrigation districts, water districts. And then also, the fact is that if somebody asks the question, is the drought over? The answer is not yet. It has eased up a bit, but it's not over yet because, like Chuck said, we are in a long series of drought. The last 2 decades have been the driest in the last 1,200 years, and so on in the West. So we are a long way from getting out of the drought. But there's more indicators to share with the audience if that's of interest.
Oh, thank you so much, Vishal. Before wrapping up, is there anything you guys would like to add? I don't know, perhaps Vishal, would you like to share some final words or thoughts with our audience?
Well, we basically have three water storages or reservoirs. One is the dams. Two is the snowpack, which melts later and provides water later in the season. And the third is groundwater. So if you look at the indicators, the reservoir storage right now is close to or above historical average. And that's good. But there's a slight limitation on that because we have these rule curves. The historical average is only does not mean that it's full right now. It's still left empty because of the rules that we have, right? In case we have too much snow melt later. So that's reservoirs. Now we look at snowpack. Snowpack is very good right now. Looking at it today, for the state, it's almost double it usually is on average for this date today. Now, if you look at the third reservoir, which is groundwater, uh, we have a long way to go, like Chuck said, because for decades we've been overusing groundwater. For example, a quick indicator I can tell you is that of all the monitoring wells in the state, 63% are below normal level. So that tells you really that this balance of using surface water and groundwater for all the different demands that we have is has been a struggle for a while and is getting much more difficult to manage and satisfy all the different needs and demands that we have. Well, I just feel like the path we are on is going to move very rapidly, which is forecast informed management, planning, reservoir operations. The quality of our forecasts are, I feel, going to get rapidly faster. They're already much better than they used to be just a couple of decades ago. And that's a good thing. So I think the ability to use these products will improve, even in a climate as difficult to predict as California, which has such great annual variability, seasonal variability. So we will see great advances, but at the same time, on the other hand, we are going to have to figure out serious demand management side solutions, because we have known for a very long time, even without a warming climate and drying climate, we have known that we just don't have enough water to supply all of our demands. So I think demand side management will continue to be a focus.
Vishal, where the listeners can find more information about forecasting of California water supply, a very interesting topic.
Well, I can start us off. I guess the sites that I go to are the PPIC blog is a great place. Then Maven's Notebook has a lot of information about water. The California Department of Water Resources website has almost a daily water conditions report. California's Groundwater Live is another web page where you can get a quick snapshot of groundwater conditions, and the California Nevada River Forecasting Center. These are some of the places you can get a lot of good information.
Oh, thank you so much for this information, Vishal, and thank you also for being our guest today.
Thanks, JC, for giving us the opportunity to share this with our listeners.
Chuck, thank you so much for your time.
Yes, thank you, JC.
Thank you. Thank you so much, everyone, and don't forget to follow us on Apple Podcasts, Spotify, Google Podcasts, Amazon Music. Stay tuned until our next episode.